All right, in this video we're going to do another application with partial derivatives, which is going to be the chain rule. Now remember that the chain rule for first derivatives, you take the derivative of the inside part. But now our quote-unquote inside part, when we take the derivative, might have x's and y's in it. And so the chain rule sort of has to extend more than what we're used to. So let's actually start with the differential from last time. So that differential was where dz was equal to the partial of f with respect to x times dx plus the partial of f with respect to y times dy. So this was the difference between the z value at the point that the tangent plane was found versus the z value, the approximate z value using the tangent plane. Now, if we wanted to take this equation now, but now find a derivative with respect to t. So if we want to change this and say let's find, let's say that dz is a change with respect to t. So it's with respect to time. So what we would do is we would take the derivative of z with respect to time. This is going to be a partial. So that change in z, it's a change in z with respect to time, because we're taking a change in f. Now remember that the function f can also be written as z. Remember that f of x, y is always equal to z. So I can substitute that in there. This first one is with respect to x, and now I have a change in x. But I'm going to take that with respect to time. And then I'm going to do the same thing for this next part. Take the partial of f with respect to y. That's what that f sub y is. But now dy, I want to put that with respect to time. So this would be a partial of y with respect to t. And this actually completes our chain rule for at least a first derivative. We'll talk about the second derivative in a homework assignment. But there is at least our first. So as a pretty simple example with this, we could just say that, let's just say that a function z is equal to x cubed plus xy, and then let's say that x is a function of x is an intermediate variable. So let's actually make our independent variables s and t. So let's say that x is equal to s times t, and let's say that y is equal to s squared plus t. And let's find the partial of z with respect to s. So if we do this, we're going to apply this chain rule, but this time instead of our independent variable being t, our independent variable is s. So instead of taking that change with respect to t, we're taking that change overall with respect to s. So we would want to take the partial of z with respect to x and then multiply it by a partial of x with respect to s. And then we would take the partial of z with respect to y and multiply that by a partial of y with respect to s. And at this point, we can kind of just find the partials and plug it in. So our partial of z with respect to s is going to be, let's find the partial with respect to x, 3x cubed plus, and let's say y is constant, so that's just going to be a y there. Then the partial of x with respect to s, t is constant, so that's all we're going to get out in front of that. Then let's take the partial of z now with respect to y. This first term is going to be constant. This next term we'll just get an x. and then take the partial of y with respect to s. So we get 2s out of it. So there's our partial now of z with respect to s. And we could put this all in terms of our independent variables, in terms of s and t, just by plugging in for x and y. But really that's kind of dependent on the application to it. Okay, so that's about it for chain rule. In the homework, we'll do a little bit of applications to this, and then we'll also extend it to second derivatives. But as far as the basics, I think that's all you need to know for now.